Good morning, friends. So today I will be covering how to do the sorting and ranking using Spark with Scala's programming language. As part of this, we will see how to invoke functions. So far we are writing lambda functions, and we are writing the logic as part of the lambda function itself. But at times, when it comes to dealing with complex logic, it will be better to create a separate function the way we have done in Python. So we will see how to do it in Scala also. There are certain differences which you need to know, but before getting into those, let us try to understand how to do global sorting and ranking before getting into by key sorting and ranking, where group by key will be used along with a top dense and function, top dense ranking function. Okay, so applying. Sorry, this is not global sorting. Let me. So for global sorting, there is another topic in the course. So here it is. So we have sort by key transformation, where we can sort the data by key. So whatever field you want data to be sorted has to be moved to the key. So first, in this case, if I want to get the data by let's say order status, I just have to make the order status as key, and then data will be sorted on order status. If you want to sort on order status and some other column, for example order status and order date, you have to make both order status and order date as key, and then you have to apply sort by key, and it will perform the secondary sort based on order state first and then order date. So whatever columns you want to use to perform the sorting, you have to apply the map function and extract those as key, and then apply the sort by key transformation function. And then collect is to collect the data, and for each println is to print the data. It is regular syntax, but this is the one which will actually sort the data. And if you want to get top 5 records, either you can use sort by key in descending order by passing false as parameter to sort by key, and then take off 5. It will take the first 5 records after sorting by key in descending order. Okay, and if you you can also use top. Top is same as sort by key of false and take of 5. It will just sort the data in descending order by key, and then it will give the first 5 records. And top and take are actions, so you don't need to apply collect when you are try to use top and take. On top of these things, as we have seen earlier with Python, if you want to sort the data on a particular field within the data, for example, we have orders have four fields, and based on order state, if you want to order the data and get the entire record, not just the order state, in that case you can use action called take ordered, and then you can actually again, when it comes to Python, it takes 2 parameters. First one is the number of elements you want to pick, and the second one is the lambda function. Here the first parameter has to be in one circular bracket, and second parameter is like this. I don't know the complete logic why they have done like this in some of the cases when it comes to Scala. In Python, it's like any regular programming language, you pass all the parameters comma separated, but in Scala it is mixed, and you need to understand the difference. If you recollect, even the aggregate by key, which takes 3 parameters, in the first circle bracket we have given the initialization, and the second circular brackets we have both sequence operator as well as combine operator, or combiner logic as well as reducer logic. as two parameters in the second circular braces, whereas in take order it takes two parameters. First one is number of elements you want to pick, you have to give in one circular brackets, and the second one is the logic you want to apply. Okay. So here ordering, so the data in this case I am trying to get order ID as I'm trying to sort based on order ID. So what I'm trying to do is I'm applying an ordering class of type int. Ordering is nothing but a class in Scala, and it has a function called reverse. And then if you want to sort the data in some order, you can actually say it here. So here I am as part of the map function, I am extracting the key and the record, and then I am sorting only on the key, and I am trying to get the results. Also, you can use this notation where you can actually create the lambda function and process and perform the map as part of the take order itself. So if you see here first I am applying the map function, and then I am applying the take ordered function, whereas here I am directly applying the take ordered function, and we have the similar logic as map function here, and it will sort the data automatically. Okay. So with map you don't typically we don't need to use map when you try to use take ordered. Take ordered itself can actually apply the transformations to extract the to sort the data on a particular column. So here are the two variations which we typically use, one for the reverse sorting, one for the sorting in ascending order. So it's pretty straightforward. You can go to this page and practice these code snippets. This is part of CCA, Spark and Hadoop developer course. And in this, if you go to the lesson transform state store using Spark with Scala, and this is the one which I have been discussing. Okay, and then the main thing, sorting and ranking using Scala by key. By key is much more powerful than global sorting. Global sorting will make it serialized, or you will not be able to use distributed computing in effective manner, and so it can be a bottleneck when you try to global sorting. When you try to do global sorting, and global sorting is not required in many of the cases, especially as I have mentioned to you earlier when I spoke about Python. If you just want to get top 3 stores within each state, you don't need to sort the data for the entire nation in US. US has 51 countries, and each state has, let's say, 50 stores, and if you want to get top 3 stores for each state, you don't need to perform the global sorting. Within the state, you just have to get what are the top 3 states. So that's what is by key sorting and ranking, and this is one of the major differentiator between traditional RDBMS and big data systems, as well as MPP also have similar logic. In traditional RDBMS, typically sorting and ranking will be serialized. That is being addressed, and here you can get up to, if you have 50 states and if you want to sort the data within each state, you can have 50 reducers, which is distributed 50x compared to traditional RDBMS. So sorting and ranking, you might not be able to get complete linear scalability, but you will be able to get as much scalability as possible. It all depends upon how many keys you have and how much data you are trying to process within each key. Will determine the amount of scalability when it comes to by key sorting and ranking. Okay, so here again, as part of this, we will also see the group by key. So far we have seen reduce by key and aggregate by key. Reduce by key and aggregate by key are primarily for primarily for aggregating the data. You cannot perform any other operations other than aggregating, such as some average, min, max, etc. But in this case, the requirement is either sorting or ranking. So we cannot use reduce by key or aggregate by key. We have to use group by key. Okay. So to perform the group by key, first we need to extract first let us define the problem statement. So the problem statement is, I want to, let me see whether I have the problem statement somewhere here. So I don't have. So the problem statement is, I want to get top 5 products or top n products within each product category. Again, if you go to the MySQL database, I'm logging into the lab. Okay, MySQL -u root hyphen, sorry, not root, retail underscore DBA hyphen P. Okay, I know what is the problem. I have to use host. Okay, so we have the database called retail underscore DB, and we have the table called products. And products have product category ID, and within each product category ID, I want to get top n products. That is the problem statement. And the logic behind getting the top n priced products, or top n priced products, is I need to extract the price, and based on the price I want to sort the data in descending order, and I want to list the products that matches those top 3 or top 5 prices. Okay. So again, as part of this data, there is one issue. One of the record have comma within I think product description or product name, which was causing the issue. Even in when we actually implemented it with PySpark also, we have seen the similar issue. So first, what I will do is, I will read the products. So let me open another window. And launching, I'll be launching sparkshell in a moment. And here it is training 8634, not Cloudera. Okay. And then I'm applying map function to get product category ID as key and record as value. Before that, I just want to filter out that one record which have comma in it. And I think which have the comma as part of the description, which was causing issue for one of the field. So here what I'm saying is val products filtered equal to products dot filter rec. So this is how we define the lambda functions in Scala. Okay. Rec dot split comma So 0, 1, 2, 3, 4 if the price is null. So that I know that one record will create will cause price to be null. So here I am actually comparing with empty string. Okay, now we can actually do products dot count to see what is the original count, and products filtered count to see if it have actually filtering that record or not. It is filtering. So here I have to define as not equal to, not equal to, not equal to, but not equal to. I want to discard that record. Now it will return 1344. So we have discarded the record which have the data quality issue. This might not be the exact solution for the problem, but I know that that record will have null in the product price, which might cause issue later. So I am filtering out. Once the data is filtered, okay, now let us do the mapping and get the product category ID. Okay, so in this case I have to do the mapping on filtered data. So products filtered dot okay, and then I am doing the group by key. Okay, now we will see how it look like. Group by is a transformation, so we have to apply actions such as take of 5 or take of 10. I will use 5 for each println. And now if you see when it comes to PySpark, it just say for each category ID an array or list, whereas here you can actually see the content of it. So this is the key for this record. This entire thing is one record for which 48 is the product category ID, and from compact buffer to this circular bracket, these are all grouped products under the category ID 48. So using this collection, now we will be able to apply advanced transformations, and as the data is already grouped by product key, product category ID, we can do whatever we want within that product category ID by applying transformation, by applying operations on collections. So this is nothing but a collection which is represented like this when we try to print the results out. So we need to be familiar with Spark based collections to do anything on these things. Okay, so now if you want to sort the data within ascending or descending order, you can do it like this. So what so this is we are trying to apply on the RDD called products group by. So products group by, I am trying to apply map function, and as part of the map function, so the input to this map function is a tuple, okay, which is this one, which looks like this, the key in that for that category and all the values grouped for that category. Okay, so that is the value, and second attribute in the tuple. Second attribute in the tuple can be represented as rec._2. So here I am converting the compact buffer into a list, so that I can apply Scala based operations on top of collections like sort by, which will sort the data, and as part of the sort by you can apply the sort by logic. How do you want to sort by? Here I want to extract the product price, convert it into float, and based on the product price I want to do the sorting. So this is how you can actually do the sorting within each group. Okay, so now if I run this command, copy paste here and hit enter. So now you can see that let me do this. Instead of 100, let me just get 1. That way we know what we are trying to do. So now you can see that it is created a list. So this is the category ID, and within the category ID, data is sorted in ascending order. You can see the last item is 999.99 or 1799.99, which is the costliest item here. So this is how you can apply group by key and then perform the sorting operations on the data. In this case, if you want to see the data in a proper fashion, you have to do the flat map. So for map function, as I have explained earlier, it will take one record as input and it will emit one record or one record as output. So one in and one out. Whereas flat map, you can flatten one record into multiple records. That's where flat map comes into picture. So in this case, if you want to get each record, each product in a separate row rather than like this, then you have to apply flat map function using which you can actually get the data. Okay, but to perform the sorting operations within the data, you have to do the map first and then you have to do the flat map. Then only it will work, otherwise it will not work. Okay, so now we will actually try to get top and priced products. So for that, you need to understand how to define Scala based functions. So Scala based function definition starts with def and then function name. And in PySpark, if you remember, we didn't specify the data types of the variables anywhere. But when it comes to Scala, you have to specify the data types. So here there is a typo. There should be, okay, it's still there. Yeah. So here we have given def, which is the keyword. We have given the name of the function, and then here I want to pass the record from using Spark based functions. So this get top densen will be applied as part of the flat map. For flat map, you will get the record as a tuple. The key will be the grouped category ID, and the value will be the list of values for that group. So we are applying get top densen function on that. So and we are actually passing the entire tuple. So here we are passing the entire tuple. So we need to give the data type of that. And how to get this one? Already we have created. We have created a RDD for a group by. So you just say products group by. So that is the RDD name and hit enter. So whatever data type it gives here, you just have to copy paste this one, because we are invoking this get top densen function by passing the entire record, which is the output for the group by key function, and the type of that record is this one, is a tuple, string and iterable string. The first one is product category ID, second element is all the products within that category ID in the form of array. So we have to just copy paste this one to be data type of this record. Okay, because that is the one which we are passing. In Python, it will inherit automatically. You just have to remember what is the structure of the data we are passing, and based on that, we have to apply the logic. Python will evaluate everything at the runtime, whereas Scala is somewhere in the middle between Java and Python. In some cases, for Scala, you have to define data types. In this case, if you don't define the data type, it will not work. And then the second parameter is how many top priced products you want to get. So here I just defined the parameter name as top n, and it is of type int. And then you also if this returns something, if this function returns something, you have to give the output type also. In PySpark you don't need to, here you have to. So in this case I want to return a list of top and priced products within each category on which the flat map function is invoked. Hence it's nothing but iterable string. Our records are of type string, so I am actually defining it as iterable string. Okay, I hope it is clear. This is the most important aspect of creating the functions. If you are confused here, then you will see a lot of surprises and it will be very tough to troubleshoot. First thing is whatever parameter you are passing, you need to understand the data type of it. In Scala it is very simple to get. Just copy paste the object name, you will get the data type of it, and then in this case you just have to pass the type of each record. Our products category, products group ID is a RDD of this type, so we are passing this each of this in one iteration. So we have to give only this one, not the entire this one. It will not work if you give the entire stuff, because we are not processing the entire collection in one shot. We are actually processing one record at a time out of the collection. So whatever data type for that one record has to be used while creating the function. Okay, and for each parameter you have to understand that, and you have to apply that data type, that as data type. In this case we are passing a tuple of string and iterable string. That's what we have defined as data type for rec here. Okay, and then if you go to the actual logic, I have created three variables: prod prices, top end prices, and sorted records. Okay, so prod prices, you will see I just initialize it to empty lists, and we will be populating those three, and then at the end we will actually return the records which falls under the top end category within each category ID. Okay, so here this is how you can loop through the records in a collection. So from our first parameter, which is rec, it's a tuple, and the first element is tuple is nothing but a category ID, and second element is the iterable. So I am iterating through the second element of the tuple. So that's why I am saying rec dot underscore to here. Okay, and this is how you define for loop in Scala if you want to iterate through an array. So it's a regular syntax of Scala. So you need to know how to write for loops on collection elements on Scala. That's what we are trying to do here. And this is another complex part and deviation from traditional programming languages. So here prod prices is nothing but a list. Okay, so what I am trying to do is I am getting, so I is nothing but this one, which will, for each iteration it is nothing but a product record within the product category ID. Okay, so here I am extracting the product price from each of the record, and I am appending to a list called to this list called prod prices, which is initialized to null. So for example, in this case, if you take this one, so we are trying to iterate from here. So this is one product and this is another product, like that. Okay, so in each product I am getting the the second product is still here. So from each product I am getting the product price. So this is the logic which is getting the product price, and initially the product prices is empty list. After each iteration I am getting the product price and adding it to the list. So this is append operation on a list. So for example, if I create list So now I have 2, 4, 5, 1. I have to say val or where. We cannot use val. So if you see here, I am using where. The reason is these are variables which has to be updated. Okay, unlike RDDs which we are trying to creating as val, where those RDDs are typically immutable. That's why we are defining it as val. But these lists are actually var. Okay, which because they are mutable, we have to append elements to these lists while processing the data. Okay, so now I have created the list as a variable, and if I have to append a new record, first let me see what is there in that list. The list have 4 elements, 2, 4, 5, 1, and if I have to append to this list, what I have to say is list equal to list colon plus. So this is, if you just say plus, it will not work. Plus is to add two values and get the result. Here we are trying to append to the list. That's why we have to say colon and plus, which will consider it as append. And if I want to append 100 to this, now you can see that the list has 100 also. Now if I say list, I will get this new element. So that is what we are doing here. Each iteration we are extracting the product price, and we are appending to the product prices. So product prices will have unsorted product prices. Top end prices, I am actually applying distinct on the product prices, and then sorting the data, and I am applying the sorting logic to be in descending order. So this is again a lambda function which I am trying to use, and then I am only taking top few products, or whatever value is passed here. Applying that, I am only getting top n prices out of all the product prices within each category ID. Okay, so let me demonstrate here with a simple list also. So in this case, let me three, 1, 2. So this is the list now. What we are trying to do is list dot. First I am applying distinct dot sort by. Here I am doing the lambda function. So x implies minus x, and hit enter. Now you can see that data is sorted in descending order. If you want to get only top few products, you just say take of 3 and hit enter. So we got top 3 products of our data. Okay, so now I just want to iterate through all the products within each product category ID, and whatever product have these top 3 prices will be stored into a separate collection, which is this one. X is another list which is initialized here to empty list, and then I am actually so before applying this, I sorted all my products also in descending order, and then I just iterate through to get top n priced products. This step is not required. If you want to make it much more smarter, you can sort all the records like this, and only and then you have to keep track how many top priced products are already done. If you reach the top end priced products, you can discard allocating into this collection. That is a little bit more complicated. I thought of doing that. That's why I sorted it, but in the end I just decided to get only get each and every record, iterate through each and every record. If that record product price falls under top and priced products, I just iterated through so that I can actually show the data in the descending order. Okay, otherwise if I don't do this, the data might not be in the descending order. In this case, the data will be in descending order of the starting with the top priced product. Okay, so I sorted all the records. So if you see here, I am getting rec dot underscore 2, which is nothing but a collection within product category ID. I am converting to list, and then I am sorting by product price in descending order. And on this sorted records, I am checking whether each and every record falls in the top end prices. If it falls under it, then I am allocating to X, otherwise I am ignoring. I can make it a little bit more efficient by just stopping when I reach the top end priced products, but I haven't included this logic. Okay, so this is how you can actually define functions in Scala. Main thing is syntax. As long as you are a good programmer, you understand syntax, you will be able to implement the logic. Okay, uh, and you can actually paste it here. Now the function is created, and if you type this function anytime, you will get the okay, I am not sure how to get. No, actually this is not. I think we just we have to only when debugging. I'm also not 100% sure. It is all about Scala. So whatever way you typically do in Scala, you have to debug in the similar fashion. Okay. Otherwise, I'll be typically careful while writing the code. I don't do debugging in any of the programming languages. As long as we can translate the requirement into a proper and correct code, that is, you will avoid a lot of issues. So I'm not 100% sure, to be frank. So when it comes to Scala, similar to Java, there is a IDE. You can actually use Eclipse itself to write Scala code also, and also there are plenty of other IDEs. Typically, people use those IDEs to debug. Okay, so you need to use underlying programming language debug tools, whether it is Python or Scala, it doesn't matter. You have to use underlying programming language debug tools. Anyway, so we have created the function here. Now I will be applying this function on products group by. Okay, and then I am applying flat map on that, because in this case, for each record after grouping by, I want to get top and priced products. The record is of type tuple, which have key and array of values in a list, or key and values in a list or array. And after applying the flat map, I will get top and priced products from each record of type tuple. So that's why I'm using flat map function here. You can see now, so the parameter which I have passed to get is 2, so I'm only getting top 2 priced products. And you can see for category ID 29, 199 is the top price and 169.99 is top price. There is only one record each, so you got only 2. Whereas for 43, 449.99 is the top price and 399.99 is the second top price. So but there are 4 records with 399.99, hence we got 5 records. So we applied the dense function, dense rank function, and get top and priced products rather than just getting the top 2 products or top 3 products. Okay, so this is how you can actually use this is how you can actually use Scala to write Spark based applications. So far we have covered all core operations, such as joining the datasets, filtering the datasets, sorting and ranking, as well as aggregations. So these are core, And on top of that, Scala also have other modules on top of core API. The first one is data frames. Second one is MLlib for machine learning. Third one is MLlib for machine learning. Third one is GraphX for the graph operations, graph related stuff. And the streaming is to stream the data in real time into Hadoop and process after that. So whatever module you use, you have to use the core API. So core APIs is the key and the foundation for rest of the stuff with respect to Spark. Okay, and when it comes to certifications, whatever components I have covered are good enough for Cloudera certification. Cloudera Certified Associate, Spark and Hadoop Developer. They cover all these APIs in both Python as well as Scala. And on top of that, they have other components like Scoop, Flume, Hive, Impala, etc. Okay, and then there are other certifications. So the HDP CD Spark is the most recent one. Before that came the Cloud CCA, and even before that there are certifications on Spark from MapR and O'Reilly. O'Reilly is partner for Databricks. O'Reilly conducts certification exams from Databricks. So out of all the certification exams, Databricks and MapR are the toughest ones. Okay, and they only focus on Spark. They don't focus on anything. And both O'Reilly as well as MapR, the certification exam is objective. They will give 70 questions and you have to get 60% of it. Sorry, 60 questions and 70% of it. So you have to get 42 questions right. And they cover everything. And they cover core APIs. They cover data frames. They cover Spark streaming. They cover MLlib, graphics, etc. But it's a objective exam, so there will be straight questions, there will be code snippets which will be given to you, and they will ask which one is the correct one you should use. Even for those two certifications, the core Spark API will be the foundation, and you don't need to know either Scala or Python. They don't test Scala or Python. They only test Spark, but still to answer the questions, I think the questions will be in Scala, so it will be better to practice a little bit on Scala. So the curriculum which I have covered covers at least 40 to 50% of what MapR and O'Reilly conducts as part of their certification exam. So the next one is CCA, which I have explained earlier, and the latest one is HDP CD. It's a subjective exam, it's not objective. I think they might give 7 to 10 questions and you have to get 70% correct. And on top of core API, they also cover data frames. They do not cover streaming, MLlib, etc. They only cover core APIs and data frames. Other than that, they don't cover anything. And they will give questions, 10 questions or 7 questions, whatever is the number. And you have to get 70% correct. So that's the pattern of HDP CD Spark. They haven't published all the details yet because it is just launched recently, seeing the demand for Spark. Hence, they haven't provided all the details the way they do with the other certifications. For example, all the other certifications, they provide practice exam in AWS. For Spark, they haven't provided any practice exam yet. Okay, so that being said, and then Pramod is asking which certification is well known with the employers. So I have written a blog which is Hadoop and Spark Developer Certifications FAQs. So if you go through this, you will understand which certification will be better. I have given all the details which I have explained here. So it depends upon your current status. Let's say if you are already HDP-CD certified with Java, sorry, not with Java, but Scoop, Flume, Spark, Scoop, Flume, Pig, etc. There is a certification in HDP-CD which tests Scoop, Flume, Pig, Hive, etc. If you already certified on that, I will recommend to go for HDP-CD Spark, because you are already familiar with you are already, if you are already familiar with HDP-CD certification pattern, it will be easy to you to give this exam, and also it covers data frames. But if you are new, completely new, if you haven't done any certifications, I always recommend CCS, Spark, and Hadoop Developer. The reason is it not only tests Spark, it will give holistic view of how to implement the applications using using big data tools such as Spark, Scoop, Flume, etc. So Gopi is asking, O'Reilly has given some references. One is learning Spark book and some exercise videos. Will that cover anything? I guess so. You have to take that chance. Always there will be a note saying that there might be beyond that. If you go for any certification instructions, but you have to rely on the information they provide. I hope that is good enough. Okay, so now we will move on to the next topic. Let's review what all are remaining as part of the course, and probably within a week we will be done. We will be done with the course. Okay, so far we have covered Scoop, we have covered Hive, we have covered Spark. Yeah, I have compared Hadoop and Spark also. We have seen Spark using Python, Spark using Scala, and the final thing is Flume and Woozy. So I will cover Flume and Woozy in next 2-3 classes, and then we'll be done. Okay. So now, so far we have seen how to get the data from relational databases. We can use Scoop to get the data into relational databases, but there will be a scenario where we have to get the data from logs, web logs. So as I have explained earlier in the beginning of the course, if you take the example of Amazon, okay, so when people go to Amazon, not everyone that goes to Amazon who search the products and who place the products in the market basket will actually check out. They might check out, they might not check out, and the miss rate is not is relatively high. It's not that only 1% or 2% people miss it. The miss rate is very high. So the Kafka and Flume overlap each other. They are not completely similar. There are different use cases where Kafka works better than Flume. Similarly, Flume works better than Kafka. Okay, and at times you have to use both. That being said, let's go back to the example which I am giving. It's about Amazon. So the miss rate is very high. I mean, when I say very high, at least 30%, 40%, or even higher can be missed. And also, not every searched product in Amazon will be bought. Okay, only probably 5% or 10% of the guys who go to the Amazon after searching the product might end up buying. Others, they might compare with other products and they go with other websites, or they might have came to Amazon only for information purposes to get the specification of a particular product. Okay, so whoever comes to Amazon to search for a product will not end up buying. And if this information is not critical for the core business of Amazon, okay, so if people buy product, Amazon have to maintain the order details of that product, and they should be able to keep track whether the product is shipped or not. If there is a return on the product, they have to support that, etc. So storing that information for completed orders is considered as a transaction, and for the transactions you will use RDBMS databases. And if you want to get the use case such as what we have been looking into about which category is performing well, or how much is the revenue for each day. If the data is available in relational database, you can use Scoop to get data into Hadoop, process in Hadoop, and you can report it. But the other data which is used for the search and all, if they start storing the data in database, and if they start extracting the data and start doing the analysis, the size of the database will be abnormally high, and it might not be able to scale up. Okay, as relational databases cannot scale linearly in most of the cases, that could be a major issue, and the database will not be able to scale up. Okay, so for that reason, companies like Amazon does not store all the data in a database. It only stores the important transactional data in RDBMS database, using from which you can use Scoop to extract the data. But the data which is being searched is important for other areas. For example, if they want to see what two products are searched together, or when they search for one product, there will be a recommendation engine on Amazon. There will be multiple other products which will be recommended below the searched product. People will be clicking on those things also. Good number of people will be clicking on those. So if Amazon can capture when a person search for a product, what other products he's actually clicking, what other recommended products he's actually clicking, that information if they capture, they can come up with they can apply the machine learning algorithms on that data, and they can come up with better recommendation engines where a visitor can become a buyer. Not every visitor need to be a buyer, but to improve the conversion rate from visitors to buyers, this information is very, very important. Okay, so that information will typically be logged into weblogs, and you have to get that data from weblogs. Okay, and Flume is the tool which you can use to get the data from weblogs. So here on CloudX Lab or Cloudera Quickstart VM, or if you set up lab using single node Cloudera distribution, I have shown instructions to set up something called gen_logs or genlogs, which stands for generate logs. If that tool is deployed, okay, if the tool is deployed, you can just say start_logs and hit enter. Sorry, start logs sh.sh and hit enter. Okay, so what it will do is, so this is provided by Cloudera again. This will actually simulate a streaming data in the as part of the log files which are generated by sample application. So start_logs, the application name is gen_logs. So if you go to the playlist setup lab, so here setup gen_logs to generate HTTP logs. Okay, so if you do that and if you follow the instructions what I have explained there, if you are using your private lab, you just type start_logs.sh and the logs will start generated. And then if you want to tail, you can say tail logs.sh, and you can see that it's a kind of tail -f. So as the logs are generated, it is displaying here. Okay, and the location where the logs are generated is cd opt genlogs So this is the location. There is a directory called logs. So you have to, if you set up manually, you have to copy, you have to download the code from GitHub account, and you have to copy under /opt, and then you have to create soft link under the user bin so that you can run these commands from anywhere. Okay. So this is the location where the logs will be generated, and lib have the directory which actually generate the logs. Lib is the directory which have the code which generate the logs. So gen http logs.py is the program which will be run when we run start underscore logs. Okay, and then let me show on under the logs section. This is the log that is being generated, and this is the data which it uses internally. Okay, it is in line with our database code. If you want to perform something from the logs that are being generated in line with our other data, such as orders, order items, etc., you can use this gen logs, and you can actually come up with some use cases where you can join data from the logs that are being generated with this tool and the data which is pulled from database, and you will be able to implement some algorithms based on that. Okay, but actual data will be under access.log when we run the start logs script. To stop, you just run stop logs.sh. Okay, so stop logs.sh will stop generating the logs, and now if you say tail underscore logs.sh, it will struck, it will not be refreshed. If when start log.sh is running, this will keep on that will keep on adding logs to this, and tail underscore logs will actually show you the logs that are being generated. Okay, so now this is prerequisite for Flume. You need to have this so that you can explore Flume little bit. I will try to use this one to explain Flume a little bit in detail, but there are much more you can explore after learning some basics on Flume. This is not complete Flume course. I will just cover the introduction part of Flume. Okay, and then we will start as part of the next class. The other topic which we will be covering is Woozy. Okay, Woozy is a workflow tool. So typically, let me open my presentation on building EDW using Hadoop. Not this one. Open recent introduction to big data. Yeah. So if you look into this, right, we have sources, we have Hadoop cluster, we have to get data either in batches or in real time from OLTP, logs, etc. And then once we get data from OLTP logs, etc. into Hadoop, we need to perform the ETL and then store the data which is fine-tuned for the reporting purposes. And if you are using typical Hadoop without Spark, typical Hadoop with Hive is not very efficient to connect to provide reports using tools like Tableau. Okay, if you use Tableau to connect to Hive database, the performance will be very bad. It will not be interactive, and if it is not interactive, people will not prefer using Tableau, so end users will complain. Hence, we cannot use Hive directly to visualize, so we will actually create a lightweight reporting database. After data is processed, we have to perform scoop export to copy the data into the reporting database from which the visualization can be performed. Okay, if you think about it, we have to get data from sources into a stage database or ODS. We have to perform the ETL, and before performing the ETL, we need to confirm that we got data from all the other sources on which we want to perform the ETL. We might have to join the data sets, one data set from OLTP and another data set from logs before joining. So we have to wait until we get data from multiple sources, and then only we should trigger the ETL process to perform the ETL and store the data into HDFS, and from HDFS we can push it into reporting. So to get data from OLTP we use Scoop, to get data from some other apps we might use some other tool. We have to wait until they both are done, then we can use Hive or Pig or whatever tool you want to use to perform ETL. Once that is done, again we have to use Scoop export to push the data to the reporting database. So this entire thing is called as workflow. Okay, and Oozie is a MapReduce based workflow tool. So this entire workflow will be submitted as a MapReduce, and Oozie have all the features that are required to create these workflows, where it can wait until data is received from all the sources, which is called as branching flow. It can branch into threads, and until all the branches are completed, it will not actually proceed to the next step, which is called as join. Once branched, it has to be joined back. That join is little bit different. That join is completely different from our data join. There we want to join after two processes are completed, two branching processes are completed, and then you can do whatever you want. There is also linear flow. So if there are no branches that are involved, you just have to define your workflow, and that workflow should be capable of invoking multiple tools. It could be MapReduce program, it could be Hive query, it could be Pig script, it could be anything. So Oozie is the MapReduce based workflow tool which will provide all these features. You can create actions on Hive, you can create actions on MapReduce, you can create action on Scoop, you can create action on shell script also, and then it will be invoked by a master MapReduce program which controls the life cycle of the workflow, and we will see all those details as part of next 2-3 classes. So the next class will be Flume, and then we will see Oozie. Okay, and Oozie also I will only cover a couple of introduction scenarios. I will not be covering too much in detail with respect to Oozie, and most of these certifications does not require Oozie except for CCP data engineer. Okay, but if you guys end up signing up for big data engineer course, there I will definitely cover Oozie in lot more detail. Here I will just show how the workflow look like and how you can leverage the documentation and start creating the workflows. And also Oozie have another component called scheduler. Typically we use cron or AppWorks or Control-M. AppWorks and Control-M are enterprise scale schedulers or enterprise level scheduler tools. Oozie have inbuilt scheduling capabilities itself. But I will not be covering scheduling a lot as part of this course. Again, as part of the main as part of big data engineer course, I will be covering scheduling part of Oozie as well. Okay, here I will only be covering workflow aspects of it, because I didn't find anyone using Oozie scheduler. Either they use Control-M or AppWorks or some other enterprise scheduler tool, or they use cron-tab, which is native Linux scheduling tool, or they use open source Azkaban or Airflow. Those are the tools which are considered to schedule the jobs. And Azkaban and Airflow, they have workflow capabilities by themselves. They are alternatives for Oozie, not only to define workflows but also to schedule. Some companies use Azkaban only to schedule. Some companies use both for workflow as well as scheduling. So I will not be covering Azkaban or Airflow here. I will be focusing on only Oozie. Okay, but those are the open source alternatives. Architecture is a little bit different. Oozie runs on MapReduce. Azkaban and Airflow does not run on MapReduce. Okay, they have their own server which will invoke these workflow tools, and as part of the workflow it will be invoking the MapReduce jobs, but the workflow itself will not be executed using MapReduce if it is Azkaban or Airflow. If it is Oozie, it will use MapReduce itself to actually control and invoke the actions defined in the workflow. That's the difference between Oozie and the other scheduling tools such as Azkaban and Airflow. Airflow is from Airbnb. Okay, so any questions so far, especially on Spark? We will wrap up today a little bit early, and we will cover these two topics as part of next two 3 classes, and we will be done with next week. So the question is, are you going to show Spark SQL? Yeah, so I can do that. It's not a big deal. So Spark SQL have two different things. One is using JDBC and get data from MySQL. It was not working for some reason. It's very straightforward. You just need to make sure appropriate JDBC jar file is used, and then the proper syntax is used, and you can write any query and which can connect to the remote database and get the data. And then there is another component called Spark SQL. There is another component called Spark SQL, which can work on data frames, which have two components, native Spark SQL as well as Hive context. So Spark can run in Hive context also. So before getting into that, Utkarsh is asking, does Amazon use Apache Mahout for recommendation? I don't know about that, what Amazon uses for recommendation. Okay. They might have their own tool. Anyway, so when it comes to open source Spark or Databricks Spark or Hortonworks Spark, they also provide something called Spark SQL. With Cloudera, they don't provide Spark SQL, but with Hortonworks or Databricks Spark or the typical Spark comes with Spark SQL, and by default I think it will be launched with Hive context. Let us see. Okay, once you launch the Spark SQL, you can actually say show databases, and you can get the details about what all databases are there. So these are the databases that are available as part of the Spark SQL. I don't think so, Mohan. The reason could be they are trying to push Impala. Unless Impala is rejected by the industry, I think they will not provide Spark SQL. It's again political more than anything else. Okay, for Hortonworks, TEDs never got traction, so they did not bother much about TEDs. Whereas Impala is a little bit success for Cloudera, and Cloudera want to push Impala for their clients to connect to data in Hadoop to visualize, to generate reports for the visualization. Okay, so Impala and Spark SQL are almost similar. Okay, so for that reason, they might not actually provide Spark SQL anytime soon. Otherwise, it is part of open source. They should be able to add as part of the Spark. They are providing as part of the distribution. The only reason is they want to push Impala. Impala neither use Spark nor use MapReduce. It uses its own daemon process. There is a process called Impala D, which will be running on all the data nodes, which will which is relatively effective than MapReduce based tools to generate reports out of Hadoop. It's much faster if you try to process lower volumes of data. Performance of Impala and Spark for the reporting purpose is almost same, but Impala chokes when it comes to processing the data, but it does not, as it does not do everything in memory like Spark. Hence, Impala is only used for reporting purposes. So in the scope of within Cloudera, if you want to implement a big data application, you have to process data using Spark and then report using Impala. Again, at some point, if clients push back, they might include Spark SQL as part of the distribution along with Impala. But as of now, it's only political. And that's what I can see, that they are not actually providing Spark SQL out of the box with Cloudera. You can rebuild the code in such a way that you get Spark SQL, but it will not be supported by Cloudera. Okay. Anyway, so as we have done in Hive, you can run use and then switch to the database you are looking for, and then you can run show tables to list the tables. We can see all the tables that are created in Hive in Spark SQL also. So Spark SQL is only command line, is just a command line interface to run sample SQL queries. These queries again have to be embedded within Scala or Python to build the complete application. Okay. So in this case, if you want to write a query, let's say you want to join orders and order items and get revenue for each day. So you can say o dot order date sum of oi dot order item subtotal daily revenue. And Spark SQL uses Hive Metastore to compile the queries, to get the metadata on the tables and to compile the queries. Okay. So instead of focusing on Spark SQL, you should focus on data frames. Spark SQL works on data frames. I will be demonstrating Spark SQL here. I will not be demonstrating data frames, but you should focus on data frames. And within the Spark shell itself, you can actually use data frames, and you can actually get the data from Hive tables, or you can define the structure on the fly. You don't need to even use Hive Metastore in some cases. If you have the dataset with with comma separated or pipe delimited fields, and if you don't have Hive table already, you can define structure on the fly and you can use SQL on top of it. So explore data frames. If you means I will be working on data frames in next 2 weeks, and you will have a lot of content available on the channel, but data frames is the key more than Spark SQL. Okay. Anyway, I will be demonstrating how you can write SQL queries in Spark SQL. It is same as Hive. The same Hive query will run. Most of the Hive queries will run in the Spark SQL, but the execution will be different. Okay. So it will use the Hive Metastore to get the metadata, and the commonality stops over there. From there, Spark will actually compile the query into a Spark compilable code, a Spark based jar, whereas Hive will compile into a MapReduce based jar. Okay, and then Hive will execute the query in as a MapReduce job, and Spark will execute the query as Spark job. So execution will be different. Spark uses in-memory feature, and Hive uses MapReduce feature to process the data once we write the query. Okay, then from orders O, here also we have to use ASCII syntax. Order items OI on O dot order ID equal to OI dot order item order ID order by O dot order date, and hit enter. Okay, it has order date, then why it is failing? So O dot order date, OI dot order item. Okay. From order so Okay. Okay, I didn't have the group by. I got it. Group by O dot order date, order by order date. Now it is running in the Spark context. And by default it uses 200 containers, I guess. Yeah, 200 containers. You can change that number by setting the number of reducers. Okay, which I don't want to get into all those details at this time. I will cover sometime later. Because it is using 200 reducers to process the data, it is taking a lot more time than usual. If you reduce that number, it will be much faster. So you can see the data here. For each day, we are getting the revenue. It took 36 seconds. If you reduce the number of reducers to be used for this, it will be much faster. Okay, so this is how you can run the Spark SQL. Any other question? Okay, then we will catch up next week. Next Monday, coming Monday, and first class will be on Flume. Second class will be mostly on OZ. If we could not cover in 2 classes, we will have 3 classes. Otherwise, we will wrap up in 2 classes. That being said, thank you. Bye.